Alright, welcome back. Let's talk about more things that are not C++. So let's go back to Java. That's where we ended last time. And let me give you an example of a just simple counter class in Java. And because I'm not sure how long this is all going to take, I definitely went and pre-wrote all of this. So I'm just going to go through my pre-written code, but we're going to make a counter class. I'm going to show you the code for that, and the idea is, just like before, we're going to make individual counter objects, maybe they're called C, and the field inside is going to be set to 0 at the beginning. Maybe we'll call that count, all right? And then we want to be able to say, like, c.inc, as we do normally. This is an object-oriented language, so we can want to do this, and the syntax should look pretty much the same as what we already know. So we'll have c.inc, things like that. That'll increment our count. If we do it multiple times, it will make our count 2 if we do it twice, for example. Okay? So we need a counter class, we need a constructor, get count, inc, reset, all that stuff. And let me show you how you can make that. So I've made counter.java for us. Let's take a look at that. Whee! So here it is, and because this is counter.java, you have to say public class counter, of course, and then your entire file, your entire implementation goes between those outer braces, and then everything inside is what you want, okay? So remember that there is no declarations of functions or methods. You just immediately give them, okay? You also can't say, okay, public colon, everything below this is public, private colon, everything below this is private. You are forced to say public this, public that, private this, private that before everything, okay? So that's a new difference between Java and C++, which maybe you've noticed already. So I had to say public, static void main all over the place. It's always public. It's always public, okay? So for a counter class, though, we have one private field, don't we? Every counter object needs a count inside of that. So that's our private int count, okay? One field called count, it's private, all right? And then we need our normal stuff. We need a counter constructor, so it looks the same, but it's public, right? Again, no return type, just like in C++, but it's definitely public because we want to be able to make counters. And what that does is it sets that current object's count to 0. So that's like as we would expect. That's not bad. Get count gives back the count of our object, whatever's stored inside. We give that back. Normally, getters in C++, we make const, right? We make const methods. That doesn't exist in Java. You can't really mark a method as const very easily. There are ways, but they're definitely beyond the scope of this lecture. And so we just have to remember to not accidentally modify count. We're forced to do it that way. Inc, though, we have it increment count in the normal way. Again, it's void inc. It's a method, though. It's public. It's a public method that we want the user to be able to use. We can also have a reset method. Maybe reset just immediately resets the counter back to 0. So you can have a dot reset. That's fine. But if you wanted to say c dot reset, don't make it 0, make it 42. Then you have to add a different method. You cannot say something like this. You can't say int new count equals 0, and like you don't need this one anymore. That doesn't work in Java. You can't have default parameters like that. So if you want a reset with no parameters and a reset with one parameter, then you need two separate methods. Okay? One without that parameter sets it to 0. One with the parameter sets it to the contents of that parameter. Okay? So that's a new difference. And so that's the first stuff. That's the first bits, and now we can make counters down here. The first new kind of thing, though, is dun dun dun. We have to say new all over the place. Okay? And remember that the main function is secretly a static method. It's part of this counter class, for better or worse. We put main inside of it, just like all the methods here. But the difference, though, is that it's marked as static, okay? All of these are not static. These are part of the object, okay? This is part of the class itself. It's a bit different, okay? So because main is static, it's not really a method that's part of any individual counter object. And so there is a difference once you say this, okay? And so here's our main function. We can make a counter. Everything that we make needs to be on the heap. So we have to say new. We have to say new to make objects, okay? And instead of, when we say new, getting back pointers, I kind of glossed over this last time, you get back what's called a reference in Java, which is like in between a pointer and a reference for C++. So what that means is you can use dot. You can use the dot. There is no arrow in Java. Okay, there's no concept of dereferencing. It's just, all right, I have something on the heap. I want to use it. I'll just use the dot. It just knows to go to the heap and get the thing and look it up. Call the method. Okay, so c.getCount initially, because of the constructor, should print 0. Then I can ink it 3 times. GetCount again should be 3. Reset to 0. Ink twice. GetCount is 2. Reset to 42. Ink 3 times. We should get 45. And so let's compile and run all that just to make sure it's working. Java C counter.java, and then that makes counter.class, and we want to run that in the Java virtual machine. So Java counter, just like that. And so 0, 3, 2, 45, and then I have one more thing that I'm about to print, and that is what I'm about to get into. Okay, so remember that public and private, they have to go next to everything. And then the final thing that I want to be able to do is have counters be added to each other, like have a counter C, have a counter C2. I want to be able to add them, to add their individual counts. Sadly, in Java, you cannot have the plus operator. You can't make an operator, you can't overload an operator, is what I'm trying to say in Java, sadly. So plus only works for things like ints and stuff with the plus built in. So we are forced in Java, sadly, to say something like this. We have to make it a method with text. We have to say something like c.add C2, which looks nowhere near as cool as C plus C2, but that's what we're forced to use. There is no operator overloading. Okay, so if I make counter C2, ink, 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 I have to say c.add C2 to add them together, and that should give me the 48 if I implement the add method correctly. So what is add? It takes ourselves and somebody else, again, they're all references, so we can just get their stuff using the dot. So we make a new count, which is our count plus the other's count, and then we make a new counter to give back, right? We're returning a new counter that holds the sum of the two that we're given, and we set its count to that sum count, and we return back that new counter. Okay, so that's counters in a nutshell. Hopefully the syntax looks very familiar, but that's why it does what it does, and those are the differences. All right, so that is our first major example of Java. Hopefully it seems not too bad, right? You could get the hang of this if you needed to know it. Let's talk about, in words, a lot of little tiny differences between Java and C++, so that you've at least heard them once. And this is a slide that I stole from Bill Kearney, so thank you, Bill, for this. Let's talk about the differences. So first difference, we talked about this a little bit last time. Java is not compiled to machine code, it's compiled to what's called an intermediate language, to Java Byte code, which is a bit different. All right, it can run on multiple machines, but it's not quite as fast because it's not yet machine code. It needs to be translated on the fly to machine code, which is a very cool thing in itself. So there are definitely trade-offs, and Java picked one. All right, it picked one way, and C++ picked another way of being compiled and being run. Okay, instead of const, that doesn't really exist in the language. You have to say public static final. It's like, all right, belongs to the class, it's a constant, and it's final, which means it can't be changed. That's essentially the equivalent of const. Instead of char, we say byte. It makes it very clear that it holds a single byte of information. Char does in C++, but it's not very obvious that that's true. Again, no pointers, only references, which, for better or worse, are the equivalent of pointers. There's just no dereferencing involved. It just does it for you. You can immediately use the dot. Again, no operator overloading. So sad. So we can't have an operator less than on our nice fancy types that we make. We have to make a dot less than operation, and you spell it out. LESSTHAN, which is quite sad. It's no fun, but that's just how it works. If you want to include a library, you import a package. Those are the two different terms. So it's import instead of include, and instead of a library, it's called a package. So it's just surface level differences. Not too bad, right? Rather than using like namespaces or includes, a package is their equivalent of a namespace in Java, and import is the equivalent of include. Okay. one interesting thing about classes that you make in Java is they all implicitly inherit from a class called object. And so we talked a little bit about inheritance. Like, do you remember that ifstream is an iStream, for example? It inherits all the stuff from iStream inside of ifstream. The same thing goes on in Java with any class. So like our counter class implicitly inherits from a class called object in Java, which has some default stuff built into it that you can override if you'd like. So look into the Java object class if you care, but that's one key difference. Usually in C++, when we make a class, it just exists by itself. And so if you want to read about inheritance and the object class, that would be the right things to search for. Okay? And then, in Java, there's a super nice way to automatically generate documentation. So when we go and look at, for example, the C++ library documentation, this is on a website that was not made by the makers of the C++ language. Java, on the other hand, the documentation comes straight from Oracle, the people who are developing the Java language. And all of this entire website, it's automatically generated from the code, which is kind of cool. And so it's very easy to document your stuff, to make big programs in Java, and that's what people love it for. Oops, where was I? I was supposed to be here. And so that's quite nice. And so that's a fun thing about Java. Finally, we have garbage collection. You don't ever have to just say delete. It does it for you. That's lovely. And then the standard library is ridiculous. You have so much stuff imported for you already, or able to be imported for you. Like if I scroll, here are all the classes that exist in the standard library for Java. It's insane. Okay? There are a ton of things. Here's all the packages. And so actually, I think this is just the stuff that's in the java.lang package, by the way. So if I click on something else, it's going to give me different stuff. So it's got a lot. It comes with batteries included, I guess, is the way to say it, right? So with that, there is a library in the default Java implementation. There are actually several that let us make graphical user interfaces, which is GUI for short. Okay, GUI, GUI, that's how we pronounce it. And so we're going to do that. We're going to make a graphical user interface around our counter class. And so here's the library that we're going to use. It's called the Swing library. It lets us make windows that we can click stuff on. It's really, really cool. And yeah, let me show this to you. So let's make a GUI for our counter class. Okay? So a GUI is a graphical user interface, and there are a lot of stuff, there are a lot of things that are pre-implemented for us in that Swing library in Java. It's called Swing. All right? And so let us use Swing to make a GUI for our counter class. Let's look at that documentation page. So here's the Swing library, some examples. And there are a lot of things that we need to make this, but the very first thing is we need to make a window, which in Swing is called a frame, a J-frame. It all starts with a J for reasons. So we need to make a frame, and that will house all of our stuff. All right, so here's what's going on. We'd like to make a GUI for our counter class. So there's our counter that we're building up, like it starts its count at 0, right? And then we're going to make a graphical window, which is called a frame in the Swing library. We're going to make a frame that shows us ways of interacting with this object. Frame. So we need to make a frame. And then eventually we need a button to click, right? We need like an ink button. We'll make an ink button. We'll make a little display that shows us our current counter's value. So that's really cool. And then we need to like arrange the button and the text field that shows us the contents. And the way that you arrange things inside of your frames is to use what are called panels. So I need to make a panel inside of our frame. It's called a Jpanel. And so I'll give you examples of this, but that's the frame, that's the panel. And then these are called, I guess, button, JButton most likely, if I remember correctly. So we're going to make a JButton that has ink on it. This is a button. and this is a text field. It'll show the contents of some text. Dun, dun, dun. So we'll say J text field. And these will be linked to our underlying counter object that's going to hold like the database for what we're displaying on the window. So if we click the ink button, if I do a little click, then what we want to have happen is we call ink on our counter, and then also this text field shows that the new value of that counter, of the count inside of the counter. Okay, so that's what we'd like to do. And let me show it to you. Let me show you how I implemented it all. So this is in the file called counter GUI. Are you ready? So we have to include the stuff that we want to use. Because I want to use the swing library, I have to import it like this. So the star just means everything. Please import everything in the swing library. Then also for button presses and things, we have to talk about what are called events. A button press is an event as far as Java is concerned. So I want to import everything that deals with events so that I can use those and handle when a user clicks on things. Okay, so here's my counter GUI program. Of course, it's in a file called countergui.java. That's the public class. And then here is my underlying object, my counter C that keeps track of the current count that I'm displaying in my window. I make it static so that I don't have to make any objects of counter GUI class. It's just, it comes with the class, all right? So we're going to use that counter class under the hood to keep track of our GUI's data. We don't have to import counter though. We don't have to say import counter or anything because it's in the same folder as this file. So Java automatically just sees it and it's happy. Okay? And then, yeah, we don't want this to be part of any object, so we make it static, this private variable. It becomes what's called a static field, and that is more or less a global variable, just like a static method is more or less a function, able to be seen by everybody. Okay? So private static counter C, we only want to use this global variable inside of our counter GUI class, and here's the main function. Here's how we set stuff up, all right? So we'll initialize our counter C to be our default counter. That's our database. That's what we want to store and reflect our visual display with the information inside of that counter object. Of course, it's set to 0 initially. And then we got to make our pretty pictures. So we got to make a JFrame. A JFrame is a window, and so we got to make one of those. JFrame frame equals new JFrame, and its constructor takes the name of the window that you want, because every window has a name. Like here's PowerPoint. It's got a window called 15 Beyond CPP. So we got to give a name. And then we also say what happens when we click the close button. What do we want to have happen for this window? Apparently the default is not to close the program, so that's weird, but we're going to make sure that when the user clicks the X, that closes our program. So exit on close, that's a special fancy constant that we'll set into our set default close operation. Okay, and then because we want to have a bunch of stuff, we want to have a text field and a button, potentially multiple buttons, then we need a panel to put all them in. So we make a Jpanel, and we put that inside of our frame eventually. Okay, so we make a Jpanel, and inside of that panel needs to go our text field that we're going to store the current count of our counter at. We're going to display it there. So we got to make a text field, and you give in its constructor how many characters wide you want it to be. So we want a 3-character wide text field. We don't want it to be editable. We're going to change it ourselves in code, so don't let the user type into it. And then the first text that we would like to see inside of that text field, so set it please to the count of our counter. The text of a text field needs to be a string though, so we use the integer library's toString method to do that kind of conversion. Okay, so hopefully this all just makes sense. It's a lot of new libraries and stuff, but the code, once you read it and you think about it, it's really not too bad. Okay, and then I also want to set the font size of this text field to be quite large, and so I've made a helper function that did that. Okay, so here's my set font size helper function. It'll set the font size of anything, any component on the window, to some new size. And so that's the fancy incantation you have to do to make it, to set the font size of your element. I definitely had to look this up. Okay, so make it a big font size, and then every time we click a button, we want to have something happen. We want to have a function called to ink our count and redisplay the new count on the text field, right? So what we'll do there is we add what's called an action listener to our button. We'll make a button called increment, and we'll add an action listener to it, and we can actually give the function that we want to call inline as part of our main function. It's really cool. We'll make a new action listener on the fly, and between these braces is the code that I want run. So here's a method defined inside of main, inside of this new action listener. This is what I want to have happen whenever this click gets made on my increment button. Please increment the original counter, C itself, and then use C to display new text in our text field. Yeah, that's what we do. That will change it all. And so, oops, that was this one. Then I'll also make a reset button in the same way that when we click it, it just resets the counter and, of course, changes the text field as well. So those are all the things that I want to have in my window. So I'm going to put them in the panel, the text field, the ink button, the reset button, and then I put the panel in the window, which is the frame. So frame, add the panel. Frame.pack just means resize the panel to just fit everything. Don't make it huge, don't make it small. Make it fit everything. And then once we put everything in our window in the proper place, we're ready to show it to the user. And this lets it be displayed on the screen. Okay, so there's a lot going on there, I know, but let's compile it and run it and watch it work. Definitely yell at me if you have any questions about this stuff. It is fun to talk about. There's just not a lot of time for a single lecture to do it justice. I know. So that made counterGUI.class, and also some of these things as well, these $ things. These are like implicit classes that need to get defined that don't really have a name. Those are like these things, because everything with methods is secretly a class. This one just has a weird name. So I'm already getting too far into things, but let's run this. All right, so I need to go over here to my virtual machine, and let me go to our current folder for today. Windows, desktop, S22 code from class, 40 online, and this is lecture 28. So now I'm going to run it here in my virtual machine. Java counter GUI. Boop. And here is our hard work right here. Here's our window called counter GUI. Sorry, it's so small. And then here's our text field, because our default counter, when it begins, its life, it is set to 0. And then here's my increment button and my reset button, just like I made. My text field, 3 characters wide, non-editable, my increment button, and my reset button. So when I press the increment button, it's going to run this code. It's going to increment the underlying counter and change the text field's contents. So if I press increment, bam, increments the underlying content, underlying counter, and then changes the count to 1 on the screen. So I can press increment a bunch of times. It's going to keep calling that function to do all the things that I need to do. And then I can press reset if I'd like to call the reset method on our underlying counter, and then also redisplay the count, because of course that changed too. So those are my 2 buttons, and I can click and I can have everything displayed to me on the screen. It's great. Yay. So that is our counter GUI file, and I can click the X and program's over. So there's of course not enough time to do all of this justice, but I hope that was a fun little example. We've never made anything graphical in this class before, because there is no default library in C++ that makes windows like this. That doesn't exist in C++, but it does in Java. It's really cool. All right, so this was the swing library, a quick little example of that. The next thing that I'd like to do is get into Python now. So let me teach you the Python language, which is another very common language that you learn first in computer science. Some schools start with Python and then they move to C++, for example. So let's make sure that you've seen at least a little bit of Python. And the reason it's called Python is not because of the snake. It's actually because of the Monty Python comedy group. And so you'll see a lot of puns if you look at the documentation for Python. And here's that website again, where you can get a little crash course in more stuff than I'm showing you here. But let's get into a little bit of Python with an example. So hello world, as usual. I owe you a hello world program. In Python, it's just a single line of code. I think you can see once I show you why this is a nice language to teach people first. No int main, parenthesis, parenthesis, curly brace. No, it's a little bit simpler to start out with Python, but that's okay. You're just cool kids now. You know, you've learned a lot. So we're going to make a file called hello. Doesn't have to have any specific name in Python. And then the standard extension for Python files is .py. And so really, it's just a single line of code in the Python file calling the print function. You say print, and you put some quotes, hello, blah, 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 closing. That is your file. That is legitimately the answer. So there is no main function in Python. You just start writing code, and it just runs it, okay? And to run our program, there is no compilation in Python. You just say, hey, Python version 3, please run my program, my original program that is written in Englishy-like syntax. You don't compile it to any machine code. Python is what's called an interpreted language. And I'll get into that on the next slide, I think. So, yeah, let's have our hello world. I guess I could do it right here. So I've pre-implemented all this stuff because I wasn't sure how much time it would all take. So here's the one line we care about, print hello world. That will legitimately print hello world to the screen. And I can run it like this, python 3 hello.py, and it prints hello world, it's fine. And then here are the comments in Python. For a single line comment, it's not double slash, it's just like makefiles. It's a number sign. That's a single line comment. And then a multi-line comment is like 3 quotes, 3 double quotes or 3 single quotes. And this is a multi-line comment. It's like a long string, essentially. And Python really thinks of it that way, in fact. And then, yeah, any code that you write, just in order, gets run. So here is essentially the one line of code that's being run, and here's me running it. Python 3 hello.py, and it prints hello world. Isn't that beautiful? So that's quite simple, I think. It's a nice language for getting stuff done. Very quick programs you can write in Python because there's not a lot of boilerplate code that you need to write. But let's talk about the differences now because I've shown you at least a couple already. So first of all, Python is what's called an interpreted language. There is no compilation. It just reads your file line by line. It's like, all right, that's a comment. I'm going to ignore it. All right, that's a comment. I'm going to ignore it. Oh, that's print. Okay, let me figure out what's inside of this, get it to a value, and then I'm going to give it to the screen, to the terminal. So it reads your program on the fly, and it has to rethink about what it needs to do each time. There's no compilation, okay? Because of that, because it has to look at your file, it's a lot slower than C++. It's a lot slower than Java. It's like, here's your file. It has a comment, and then like it's got print 2 plus 2, then it's got print hello world. If this is your Python program, it needs to run, when you run Python, it needs to look at this entire comment line and notice like, oh yeah, I don't have to do anything there. This one, it needs to always remember to go and do 2 plus 2 first before it prints it. And then this one, it's like, all right, I've got a string, I'm ready to print it. And it ends up printing 4 and high. But it did a lot of work. It has to read the file character by character. It has to essentially parse English-looking stuff. That is very slow. Okay? So it's much slower than C++ or Java because of that. Gosh, let's see. Let me do all this in another file. I think I started another file for this. This is more python.py. And let's get into this kind of stuff. So first of all, there are no types in Python. Python just figures out the types of things. So for example, I can just say x equals 2. I don't say int x equals 2, I just say x equals 2. It's fine. It knows that it's an int. And so Python, when I print the x, it'll print the 2. It also keeps track under the hood of the type of x. So there's a function called type that will that I can run and say, hey, Python, what's the type of this variable? And so let's run all this. And so the first 2 lines, it was like, all right, it's the number 2, and it was an int. So it knows that it's an int. Python, though, is what's called a dynamic language and has dynamic typing. So it just figures out the types for you. That's what it's really called. That's the technical term for what it means when Python figures out the types for you. Because of this, though, if you use the wrong types, Python's not going to warn you. It's just going to throw an error at runtime. It's going to give up trying to run the program. It's crazy. So yeah, you just say, All right, let's use X. Hope for the best. Also, because it's dynamically typed, I can do this, and this should make you feel very uneasy. I can say X equals a string now, because even though X used to be an int, Python's okay with that. It's like, all right, yeah, sure, X can be a string now too. So it'll print, if I print X, yeah, it's fine, prints ASTF. And then the type of X is str now, str for string. That's crazy. Isn't that weird? So yeah, dynamic typing, crazy looking. If you want a function, this is what functions look like. This is a function that gives back 1 plus what you were given. It's a function called add1. So I can say add1 of 42. It's supposed to give back 43. And so here is the definition of the add1 function. And because there's no types involved, there's no return types. You just say def to start a function. And also there's no type for the variable here. It could be an int, it could be a double, anything that plus works with, it'll be happy with. That's fine. What you can't do, though, is call it with a string, because it's going to get here. It's going to try to add 1 to a string, and it's going to throw an error. It's like, bam, type error. During runtime, it comes up with that issue. It notices the problem. So that is, that's Python in a nutshell. You are just forced to keep track of types in your mind. And if you do it wrong, it's going to bite you during runtime. There's no way of ahead of time noticing that something's going wrong. Okay, so that is the add function, and there are no curly braces in Python as well. You say def add, then you give a colon, and then you indent. Python is all about white space. All right, so the body of this function is everything that's indented. Once you stop indenting, you're back at the original code that's outside of everything. But the contents, the body of this function, is the indented code. Okay, so return y plus 1. There are also no semicolons in Python. It's just, all right, the new line is what gives me the next thing. I can't put multiple things on the same line because of that. Multiple statements. It's just one statement to a line. There are no braces, so you got to indent, and no semicolons, so you have to press enter when you want to do a new line of code. Okay? So white space matters. You have to tab over to get the body of a function, and no braces, just white space, which is crazy. Crazy to think about. Instead of arrays in Python, we have lists, and this is what the syntax for lists look like. It's these just angle brackets, and so this is a list of 3 things, 1, 2, and high. Python is a dynamic language. Again, it doesn't care about type, so I can have a list of a couple numbers and also a string. Crazy. This is the string high. In Python, for strings, you can either use double quotes or single quotes. There is no difference. It does not care. So most Python programmers actually use single quotes to make strings, believe it or not. And then indices work as normal. So L of 2, that's the high, right? It's going to print high. So that's lists. What else? Here are if statements, very similar to our function definitions. Like if you want an if statement, you actually don't need parentheses around the condition, but you do need that colon, and the body is tabbed over. Right? So here's like a grade printing program, set grade to 77, and then this is if grade is greater than or equal to 90, print A, else if grade is greater than or equal to 70, print C, else print F. So it's a bunch of colons and indenting, no braces, okay? Instead of else if, it's elif, slightly less things to type, so I guess that's why they chose that, and yeah, that's the idea. Let's see, when we make methods, I'm going to show you how to make a class on the next slide. When you make methods in Python, you have to talk about secretly, or you have to talk about explicitly that secret this parameter that I told you about in C++ when you have methods. There's secretly that this parameter, that's the first secret parameter that's being passed when you call something. In Python, you have to explicitly talk about that when you declare a method, when you define a method. And that in Python, instead of saying this, they say self. Okay? And just like Java, the libraries in Python are amazing. They are so good. Maybe even better than Java these days, the Python libraries are. If not the default ones, the ones you can download off the internet, everybody's making Python libraries these days. It's awesome. So that's another reason to want to use Python. Okay, so let me give you an example, again, of a counter class and show you what's going on there, and we can compare and contrast. So here is my counter.py program. And here's how you make a class called counter. Okay. You want to use it like this again, as normal. So C equals counter, no types involved, no new or anything. You just call the constructor. And then you can say c.inc, 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 all that stuff. And you can say c.getCount, should be 3 here. And you can make another counter. You can give a parameter to the constructor to set the default count to a certain value. I'll show you where I implemented that. And then if you inc it twice from there, it should be 44. So this is why you see this output. Oops, just like that. And now let's talk about the definition of this class. So it's class counter, and again, colon, indent everything you want to be part of the class. All right? And then you start giving the methods, and you indent everything that you want to be part of the method body. All right? In Python, you have some weird names involved here, though. Constructors, for example, are called init. And it's not just init, it's underscore, underscore, init, underscore, underscore. Very special name, okay? And every method in the definition, not in the use, in the definition, takes that secret first self parameter, okay? So really, this is a method that takes nothing. When I say inc, I just say nothing, but it's implicitly being passed this self, and we're explicitly saying it in the definition, okay? So for the constructor, you take yourself and you give a count. You can give default arguments. That is totally fine. And so this is the constructor. Because you can't really do things ahead of time in Python, you actually make the fields on the fly inside of the constructor. So notice I'm not defining the count field anywhere right now. I'm doing it inside the constructor. I'm going to make the field called count. I have to make it in the constructor. Here's where you do it. If I want a field called count in me, I say self.count. That's why you pass along yourself. I say self.count equals whatever was passed along here. Okay? This is where we make a member variable. It's crazy. So that's the counter class. And so you call it like this, counter parenthesis parenthesis, and it's just implicitly passing along that initial object. Okay? A self. Likewise, when I'm calling inc, I'm incrementing self.count. Right? That's how you get at your member variables, at your fields. And so when really I say c.inc, it's secretly making this a function, and it's calling inc of c, right? That's why it's getting c here and saying c.count plus equals 1. It all works out. Okay? So hopefully that makes at least a little bit of sense. But explicitly say self here, and it implicitly gets used for you here in the call. There are no parameters when you call it, really. Okay? And so get count is the same, return your count, but you got to go through yourself. And so that's why this works like this. That's why it prints 3 and 44. I hope that makes sense. So yeah, again, in C++, it was like this. It was always, you have your current object that you've just been called a method on, and you have some fields or whatever, got a count field, for example, and then this, the keyword this, when you're inside of that method, is implicitly being set for you in C++ to be a pointer to your current object. In Python, that's what's happening. It's using self instead, and you're explicitly saying it when you define things. Okay? So please yell at me if that does not make sense. Also, this this documentation page might have a different way of explaining it that might be easier to understand. But that is classes in a nutshell, and that is our counter class. The second to last thing I want to show you is a really cool library that's baked into Python. It's called the Turtle library. I like to use it in my CSCI 1 class because it's graphical. You get to draw things. And so here's the metaphor. It's a library, again like Java, we import instead of include. So we're going to import the Turtle library, and it lets us draw stuff programmatically. So here's the metaphor. It's like there was a turtle, and somehow this turtle got its tail dipped in ink. Something happened, some freak accident. And the turtle it will respond to your commands. He can put his tail up or put his tail down onto the ground. And you can ask the turtle, he is sentient, he responds to English commands. You can ask him to move with his tail down, and he'll draw a line. You can ask him to turn with his tail down. He'll keep drawing that line, but now make an angle. And you can do this. You can keep telling him to do stuff, and you can draw like squares and things. You can draw triangles. So let me show you how to draw stuff with the turtle library. So definitely this is the documentation page to look at, but there's a lot of stuff going on here. You can change the color that the turtle's going to draw with, and then here's what we're mostly going to be using today. Hey, turtle, please go forward. Hey, please turn left or right by a certain number of degrees, things like that. And so here is my program. It is turtleexample.py. And so here are some calls to all the things. So when you import a library in Python, to use the functions defined in that library, you have to say the library name with a dot at the end, with a dot before the name of the function. So if I want the speed function inside the turtle library, I need to say turtle.speed, right? So I set the turtle speed to very slow so we can see him move. I set the turtle shape to a turtle because by default he's not. He's just a little arrow. We'll make him a cute turtle. And yeah, there's always a concept of the current window. So the window will open up, the turtle is going to exist, and the turtle starts out facing east, we say, at the coordinates 0, 0. So that's our turtle. And then if we have him move forward, he will start moving in this direction. If we want him to move anywhere else, we have to change his orientation. Okay? So for example, I can make pink, I'll make a pink square, and this is how you make that square. So let me comment out the rest of this for now with a multi-line comment. At the end of your program, you say turtle.done to just not close the window or anything, just keep it open. So wait after you've drawn stuff. So here is us drawing a pink square. Let me make it work for you. So let's do this. Here it is here. Here's the code, and let me run it as well. Boop. And so there he goes. He's moving, he's turning. Hopefully you can see the pink square that got drawn. And now he's waiting for me. So here's what happened. We said turtle, he was facing east, go forward 100 units, and then he moved 100 units. And then we said turn left 90 degrees, and then go forward 100 more units. So that was this upper part. Turn left 90 degrees again, go forward 100, turn left 90 degrees, go forward 100. Now he's back where he started, facing down, and that's the end of the story. So that's how you draw a pink square. So let me try and do this and this. Hopefully you can see it work with the code next to it. Sorry, there's not a lot I can do there. Then here is how you draw something fancier. What is this? This is going to be a triangle. Boop. An equilateral triangle that's blue. So I can change the pen color. If I want to move the turtle, if I want him to move and not make a mark, I can tell him to pick his tail up, and then I tell him to go forward 200. That gets me into the place where I want to draw the triangle. So he ended up right here. I told him to go forward 200, which brings him down to here, where he is now actually. And then I want him to move according to these rules. Put your tail back down and then draw your triangle. Okay? That's essentially what's going on here. So with that in mind, let me rerun the program. So draw the square, pick the tail up, go forward, get into the spot where I want to draw the triangle, and then just move in the way that draws that triangle. Isn't that cute? So this is a fun little library to teach people programming with, and I like to use it in my CSCI 1 class. And the reason you have to do it in all this way is, let's think about this. Why do I have to say turtle.left 180 minus 60? Here is the idea. So at the very beginning, let's see. I say the turtle is facing downwards, we went forwards in the down direction, then we turn left by 90. So we did this. The turtle is now facing this way. Yeah? We're facing in this direction. And then we ask him to draw the bottom part of the triangle. So we say forward 100. Forward 100. And then we want him to move this way so we can draw this part of the triangle. So how much do we need to turn? We need to turn left, right? But what's this angle? It's like if you went forward, you got to go this way. We need this angle right here. That's how much to turn by, right? In that direction. This is, well, this plus this adds up to 180. I know that a triangle has an equilateral triangle, at least, is 60 degrees everywhere. So this side is 60. So what is this but 180 minus 60? And so that's how much you need to turn to get over here onto the right track. And then again, it's, all right, turn that same amount, right? 180 minus 60 to get going this way and to draw the rest of the triangle. So that's why it works like this. One last time for fun. Square, and then triangle. So I think you can imagine with enough functions built up, you can draw really cool looking stuff. So that's the turtle library, and yeah, that's what I wanted to say there. So final thing for Python is if you just say Python by itself, it opens up what's called a REPL. Python 3, it opens up what's called a REPL here, and you've seen me use this before. A REPL stands for Read, Evaluate, and Print Loop. Okay? And so it reads your code. You can type a single line of Python code, and it runs it. Hit enter, and it runs it. And then you can type something like X, and it implicitly wraps a print around that to print to you whatever it gives back. And so this is really nice for math. Like, what's 2 plus 2? What's 42 times 42? The squared, the power operation in Python is 2 stars, so 42 star star 2. And yeah, Python by default has very large numbers. It has infinitely large numbers, so you don't have to worry about making a number too big for an integer to keep track of, for example. So I can ask for, hey Python, what's 2 to the power of, I don't know, 10,000? Apparently this is the answer, and this would never fit in a C++ integer, but Python is fine with that. This is the answer. That's 2 to 10,000. And yeah, that's Python. You can say quit. You can call the quit function to end the REPL environment, or you can just type Control-D to send the end of file character to also stop it. But that is everything that I wrote down to show you guys today. So that is a taste of Java and Python, and I hope you learned some stuff and you had fun. Again, I'm not going to test you on this. This is just for your knowledge so that you can learn new programming languages and notice that it's not too hard. Definitely look at these pages for more information and ask me any questions. But yeah, this is the end of the content for this class. Next week is the week before finals, and all I want to do then is review. So I will see you next week for the review lectures.